Okay, good morning class. You guys had some homework? Correct? And it was on page exercise 5. And exercise 5 is on page so you had to do number 1 and 2. Not so? Okay. Any problems you had with number 1? Any problems with number 1? Number 2? 2.2. Determine the sum of the first 40 terms of the arithmetic series. Exercise 5, page 14. Determine the sum of the first 40 terms of the arithmetic series. Do we have the last term? No. So we follow the formula. Sn is equal to n over 2 into n minus 1 t. If you really wanted to use the other formula, you could have worked out the general term, then you work out the value of term 40. Then you can use that other formula. So then you must have the last term, the 40th term. Does that make sense? But yeah, we don't need the formula. How do you move from term 1 to term 2? Subtract 4. No, 6. Subtract 6, subtract 6. Not so. So that's my D value. So how many terms am I working on? Is 40. It's equal to 40 over 2 into 2a, which is 16, plus n minus 1 times negative 6. Alright, so what do we do now? Just sub it into the calculator. So what confused you here, Michael? So easy, no? Let's hurry, this must be 40 minus 1, which is 39. Negative 4 over 4. Is that the right answer? Any problems here? Any problems? So yesterday we only did one example, not so. We spoke about those two terms. Example 2 is the same as number 2. Let's look at example 3. Example 3 is on page 13. Okay. So now we have the sum of n terms is equal to 2n squared plus 9n. Okay. The question says find the first three terms of the sequence. Remember here we got given Sn. They want you to work out the first three terms. If it was given as Tn is equal to 2n squared plus 9 or whatever, and it was a general term, then I would have substituted term 1, term 2, term 3. Not so. However, this here we have the general term for the sum of sequences. There is a difference there. So I just need to bring your attention to something different. Okay? If you are given term 1, term 1 is the same as the sum of one term. Not so. Okay. We go S2, that will be term 1 plus term 2. Not so. What if we go with S3? T1 plus T2 plus T3. What if we go S4? T1 plus T2 plus T3 plus T4. What if we go with sum of n terms? It's going to be T1 plus T2 plus T3 plus the last term, which is Tn. Not so. So S1 is going to be the sum of the first term, S2 is going to be sum of the first term and the second term, S3 sum of three terms, S4 sum of four terms. As you can see there, that is the last term that corresponds to that there. Sn is going to be all the way to Tn. You will agree with that? Okay. So what we do now is we say, okay, S2. Let's start with S2. S2, remember what is T1 equal to? Sorry? S1. So S2 is equal to S1 plus T2. Not so. Look at the next one. What do this one be? T1 and T2 is what? S2. Which implies S3 is equal to S2 plus T3. Look at the next one. So this is going to be S4 is equal to S3s plus T4. What will the last term be? This will go all the way till we, the one just before that, not so. And what's the last term here? T n minus 1. And here? T n minus 2 and so on. Not so. So in other words, that would simply be Sn that would simply be Sn equals S n minus 1 plus T. You all agree with that? Okay. So what will happen if I make T2 the subject of the form? So that would simply be T2 is equal to S2 minus S1. T3 will be equal to S3 minus S2. What would T4 be? S4 minus S3. What would T12 be? S12 minus S11. What will term 168 be? S 168 minus S 167. You all understand this concept? Okay? So what would Tn be? Tn. So it will be Sn minus Sn minus 1. Okay? What would term 1 be? It's just simply S1. Term 1 and S1 is the same. You all understand that? So write this down and I'll show you how it fits into what we're working with. Let's pause the video. So, to work out the first three terms, I need to know what S1 is. I need to know S2 and S1. For term 3, I need to know S3 and S2. Can you see that, people? Does it make sense? The first three terms, I need to know the sum of the first term, because the sum of the first term is the first term. I need to know the sum of the second term and first term. Why? If you subtract it, we're going to get term 2. Looking at term 3, if I subtract S3, the sum of 3 terms, and the sum of 2 terms, I will get the third term. Does it make sense? So, what's the first thing we need to do? We need to work out the sum of the first 3 terms. Okay, so whenever you get the sum, you first work out the sum of the first 3 terms. Okay? How do we work out the sum of the first 3 terms? We just do the substitution. It's 2 times. Wherever I see an in, I put a 1. 1 squared plus 9 times 1, which is 11. Then, term 2, so it will be 2 times 2 squared plus 9 times 2. You all okay with that? And the same with term 3. So do that with me. Alright, so term 2 gives us what? It's going to be 8 plus 18 is 26. The next one is going to be 2 cubed, 2 times 2, yeah, it was right. 2 times 3 squared plus 9 times 3. So it's going to be 9 times 2 is 18 plus 27, 45. So that is the sum of the first 3 terms. The sum of the first 3 terms is 45, sum of the first 2 terms 48, and the sum of the first term is 11. So what did we say? Sum of one term is equal to T1, which is equal to, sorry, 11. For term 2, what would that be? S2 minus S1, which is 26 minus 11, which is 15. You guys okay? Term 3, how are you going to work out term 3? S3 minus S2, 45 minus 26, which is 19. Determine the first three terms of the sequence. So what are the first three terms? 11. Is it the sequence or the series? Sequence. So what must I have? Semicolons or plus signs? Semicolons. So it's going to be 11 plus 11 then 15 then. You all understand? Is anybody that's confused? Any questions? Determine the 12th term by using the formula. Sn is equal to 2n squared plus 9n. So how are you going to work out T12? T12 is equal to? Sorry? S12 minus S11. So do your thing really quickly. This question comes often in the exam, no? Okay, so what do we get? So what do we get, people? It's 12. It's going to be 2 times 12 squared plus 9 times 12. Minus is 11. It's 2 times 11 squared plus 9 times 11. What does that give us an answer of? Am I moving too fast? Yes, okay. Give me a chance to catch up quickly. Again, for T12, using the formula, the Sn formula, it's going to be T12 is going to be S12 minus S11. What if they had asked you for T43 to work out term 43 using the formula? It's going to be S43 minus S42. Just one less. What did you guys get? Sorry? 55. 55 is good. Okay. In number 3, they want to know, determine the 12th term by determining the formula for Tn. So how are you going to calculate the formula? What's the formula for this general term? The general formula, sorry. Tn is equal to A plus n minus 1d. Okay, so do your thing quickly and then you work out term 12. Pause again. So as you can see, you got 55 in both cases. You could have used any one of the two. However, if they specify as they did in this question, you would have to do what they asked you to do. Okay? So Tn is equal to 11 plus n minus 1 times 4. So it's going to be 4n minus 4 plus 11 is positive 7. So therefore T12 is going to be 4 times 12, which is 48 plus 7 is 55. And as you can see, they are the same. Is there any confusion here, people? Any confusion? No? Alright. Alright, let's look at example 4. What's example 4? It's on page 14. Okay, work example 4 on page 14. Always write your reference down so that we know where's the homework coming, where the sum came from, which exercise, or which example. The second term of a sequence is 17. The second term of a sequence is 17. So what do I write there? T2 is 17. The sum of the sixth term, the sum of the first six terms is 147. The sum of the first six terms is 147. So what do I write there? S6. Okay. Determine the first three terms and the nth term. So in other words, we must calculate A and D. Not so. Let's calculate A and D in order to sort this out. Okay. So we write that T2 is equal to 17. S6, the sum of the first six terms is 147. Did I tell you if it's arithmetic or geometric? No. But here we know it's going to be arithmetic. Why? So we only dealt with arithmetic formula at this point. So it's a slip from this side, because we didn't do geometric yet anyway. You understand? So just add there. It has to be the first three terms on it's an arithmetic sequence. Right, so what do I do for T2? What's a general term for arithmetic formula? Tn is equal to A plus n minus 1 times D. So what would it be in terms of T2? A plus 2 minus 1? 1D is equal to 17. Drop that. Okay. So what I do is I take it over the equal sign. So A is equal to 17 minus D. Equation 1. How do I know I'm going to go into simultaneous equations? Huh? I don't know. There's two unknowns. There's an A and a D. So most likely we are going to go into simultaneous equations. Does it make sense? Do we have the last term for S6? Do we have term 6? Huh? Where do you have term 6? We have term 2, yes. If this was term 6, then I would have said Sn is equal to n over 2 into A plus L. So I have my last term, the 6th term. Do I have my last term in this case? No. So which formula must I use? The other one, which is Sn is equal to n over 2 into 2A plus n minus 1D. And what is your n in this case? 6. So there's going to go 6. 6. So what will this be now? S6 is what? 6 over 2 yes into 2A yes plus 6 minus 1. What's 6 minus 1? 5D. And this is equal to 140. So what can be done now? What can be done now? Divided by 3. What's 147 divided by 3? Is it divisible? What is it? 49. So I divide by, because that is going to give you 3. So I divide by 3 both sides. So I'm going to get 2A plus 5D equals 49. And that's equation 2. So what do you see now? What do you think we're going to do now? Simultaneous equation. Substitute equation 1 into equation 2. So do that quickly. And then pause again. Alright, so as you see, it's going to be a simultaneous equation. So it's going to be, if I see A, I put a 17 minus D. So it's going to be 2 into 17 minus D. Okay. Plus 5D. equals 49. So what do I do now? Solve for D. Get rid of this. So 7 times 7, 17 times 2. Sorry? 34 minus 2D plus 5D equals 49. Now what? D's one side, numbers other side. So it's going to give you minus 2D plus 5D is going to be 3D is equal to 49 minus 34. Sorry? 15. So D works out to be? Ever answer the question? No. I need to know A as well. So that will go into equation 1. So A is equal to 17 minus 5, which is 12. So what is the first 3 terms of the sequence? 12. Then we're adding 5, which is 17. This is A plus D plus A plus double twice D and so on. Will give you 22. But they haven't answered the full question. No. They want to know the nth term as well. So what do I say? Tn is equal to A plus n minus 1D. What's your A value? 12 plus n minus 1 times 5. So it will be 5n plus 5n plus 7. Okay, any confusion here? No confusion. Okay. That was question 4. So with that you should be able to complete exercise 5. So exercise 5, number 3, 4, 5 and 6. That's on page 14. That's your homework. Okay. Now I want you guys to read for homework through page 15 on top there. It speaks about the sum of geometric series. The sum of geometric series. What's the difference between a sequence and a series? Sequence has semicolons, series has plus signs. Everything else stays the same. Okay. The formula for determining the sum of terms in a geometric sequence requires each term of a series. Okay, so what I'm going to do is I'm going to prove this this formula now to you. Then we're going to look at those examples quickly. Okay, so we are required to prove RTP. Again, I'm going to send you the link. Okay, the formula is the simple paste. I'll send you the link as soon as I phone back. You got these 2 proofs in that video. Okay. So you can watch it just before you write again. Well, first master it, and then just before you write, make sure you can watch it again, just to refresh your memory. As I said, how many marks will that sum? 4 or 5 marks. Okay. Sometimes 6 marks. So you're required to prove RTP Sn equals A or n minus 1 over r minus 1. Now sometimes they give it to you like this. Sn is equal to A 1 minus r to the n over 1 minus 1. You all agree that both of that is the same. So if I swap this around and negative comes out, if I swap that around and negative comes out, negative divided by negative is that positive. Not so. Any confusion there? No. So that is what we require to prove. Again, when I ask you to when you are required to prove, do not use that formula in your proof. You must end off with a formula. Okay, are you all okay with that? So Sn for geometric sequences. What is the general form for a geometric series sequence? It will be A, the next term will be AR squared, not so? This is a series plus, so this is going to be AR n minus 1 plus AR n minus 2. You all agree with that? That is the sum of the series. Okay? You all okay with that? So what did we do when it was arithmetic? Took that whole a general term and we swapped it around and then we added it. Not so. Here we're not going to do that. Here we're going to multiply the whole line by r for the common ratio. Okay, we're going to multiply the whole line by r. So what is Sn times r? R is it. Not so. What is 8 times r? Here. I'm going to put like terms one below the other. Are you all okay with that? So when I multiply this line by r, I get AR. When I multiply this by r, what am I going to get? AR squared. All okay with that? If I multiply this by r, what do I get? AR cubed. Not so. What will happen if I multiply AR n minus 1 by r? What will I get then? AR n. Not so? Because it's a 1, yeah? What's minus 1 plus 1? 0. So it's AR n. Not so? Is there any like term to that? No. So that would be on its own. Yes? Remember, I'm multiplying this line here by r. Not so? So we're going to give the last term AR n minus 1 multiplied by r. This is r to the 1. When you're multiplying and base are the same, what do you do with the exponents? You add it. So it's n minus 1 plus 1. So it's going to be AR n. Verstaan jy? You understand, Michael? Nice. So we said we're going to get AR n. The 1 per r, if I multiply this by r, what am I going to get? What am I going to get when I multiply that by r? Sorry? AR n minus 1. Not so? You all okay with that? What if I multiply the term prior to that with the r? AR n minus 2 and so on. Does it make sense? AR n minus 2 and so on. So what I do now is I draw the line, and as I did before in the arithmetic, we added both terms. Not so. What do you think we're going to do here? Subtract y, so it can cancel. Not so. So I go throw out with negative in. Multiply by negative. So what is Sn minus r is n? What is Sn minus r is n? Are they like or unlike terms? Unlike. So it's going to be Sn minus r is n. I know some of you want to say or, no? Don't. Unlike. No? So is there any like term to a? No. So that's going to write a then. Not so? What is AR minus AR? 0. What is AR squared minus AR squared? 0. What is AR n minus 2 minus AR n minus 0? A times r to the n minus 1. Cancel. So what are we left with? Plus or minus? Negative. AR n. Not so? So what do we see here? We have a. What do we have here? Say it. What do we have? Common factor, yes, of Sn. What are we left with? 1 minus r. On the other hand, what do we have as a common factor here? Huh? A. If I take a out, what are we left with? 1 minus r. Ever done the job? No. We must add here now. Therefore, how do I get SN on its own? We divide both sides by 1 minus r. You see that? So Sn is equal to A, open brackets, 1 minus r to the n over 1 minus r. Can you see that, people? There's a restriction here for r. What can r never be equal to? 1. Why? Will be undefined, not so. R also can't be 0. R can't be these values, 1 and 0. I'm not too sure about 0. I think it's not 0. Just leave it out there. I almost want to say it can't be 0. I'll just check. Yeah, if it's not going to be 0, it won't be arithmetic. I mean geometric. You see that? But I don't see they're writing it down here. So let's just leave it like it. R can never be equal to 1. If they'd ask us to do it like this one here, the R is first, then what we do? We just swap that around, and we'll get exactly the same. You guys understand? But by doing that, we already give you 5 marks. Okay? Yes?
So, I'm sorry, could you do the
Cancelling
cancelling process?
process.
Yes.
Where? On top.
Yes.
Okay. So what we're saying is, remember at this point we had Sn is equal to A plus AR plus AR squared plus and so on. AR n minus 1 plus AR n minus 2 and so on. Not so? So what did we do? We multiply this whole line by R. So we got R is in. Then we got A times R is AR. AR times R is AR squared. R squared times AR cubed. The last term times R is going to give you AR in. If I multiply this by R, I'll get AR in minus 1. If I multiply this term by R, I'm going to get AR in minus 2. You understand? So what do we do now? So we said we're going to change the signs on the line. Why? So that we can subtract. Okay. So this sign, change the sign here, multiply it throughout by negative. So Sn minus R is in. It's unlike them, so it's Sn minus R is in. AR cancel AR. So I'm just left with that A there. AR squared minus AR squared. AR in minus 1 cancel AR in minus 1. So we're just left with minus this one here, which is minus AR in. So what do you notice? We've got the common factor here of Sn. So we left with 1 minus R equals, A is common there, 1 minus R to the n. So how do I get Sn on its own?
Good morning. May I have your attention, please? The following learners can you please report to the office? Blessing Ludekaife, Denisha Coleman, can you please report to the office? Then all Kenyan House learners, can you please report to the hall? All Kenyan House learners from grade 8 to grade 12, please report to the hall. Thank you.
Okay. Any problems here, people? Okay. So we will look at the examples. Oh, we got 5 minutes left. The bell ring now. Sorry? Oh, it's Wednesday. You like to carry on during break? No. Aren't you guys matric? You must be sacrificed now. All your life you were living a easy life. So you must, don't close your face, Michael. So you must sacrifice. But okay, let's stop here. So you guys have homework, no? What is your homework? Exercise 5, the remainder of the exercise, and the paper 1 and 2 of last time. People, enjoy the rest of your day.